Alright, so 5.3, day 2. You should be able to get through all the notes today. Here's a warm-up from what we did yesterday. From the part... Well, okay, from the previous day. For those watching this video, it's Monday, and Colton quickly pointed out that yesterday was Sunday. Thank you, Colton. Alright, so see if you can find the tangent of theta if the angle goes through. Find the secant of theta if theta goes to the point -3, 5. And it's assumed that the angle is in standard form. Alright, try these problems. Alright, I'm hearing some good progress by quite a few people. I just want to make sure everybody understands what's going on. I'll help you with the first one, then hopefully you can complete the second one. So the point 4, 6 is in what quadrant? Quadrant 1. Somewhere up here, we'll call that 4, 6. Here is my angle. Okay, so we can draw our triangle. If it's 4, 6, that means I went over 4 and up 6. Do I even need the hypotenuse here?
No.
A lot of you probably figured it out. What is that?
Square root of 52.
36 plus 16, square root of 52. Very good. But we're actually asked to find the tangent of theta, which is just opposite over adjacent. So the tangent of theta is 6 over 4. So 3 over 2 would be the simplified. So 3 halves. -3, 5. Make sure you're drawing it up in quadrant 2. Alright, so -3, 5 is in quadrant 2. So we'll draw it. -3, 5, I'll call it right there. And then I gotta make my dot a little bit bigger, make sure it goes through it, and there we go.
There we go.
Alright, so I have my reference angle theta right here. We can label the sides. If that's -3, 5, that means I went left 3 and up 5. Remember, if you have normally we wouldn't say negative distance, but since we're going to the left, it's negative. Since we're going up, it's positive, which makes the hypotenuse 25 plus 9, 34, so square root of 34. Alright, so we're now ready to figure out what the secant of theta is. So secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse, so the secant would be hypotenuse over adjacent. So it would be negative square root of 34 over 3. How many got that right?
Wait, is it not negative? I was close. Oh.
So the negative fraction, you just put it up front.
Yeah.
Yep. Okay, so that was one type of problem we talked about last time. I also asked you to find, we'll say number 3. Let's say I wanted you to find the sine of 30 degrees.
Nope, I ran out of room.
Okay, this would be a non-calculator problem. So you need to draw a 30-degree angle, use special right triangles, label the sides, and then figure out the sine. I'm also going to ask you the tangent of 30 degrees, and I'll ask you the cosecant of 30 degrees. So all the same angle, so just draw one triangle and answer those 3 questions.
30 to 6. Sorry, I found it.
Alright, so 30 degrees. Here's our special right triangle. 30 degrees, across from 30 is always going to be 1, the hypotenuse is going to be 2, and across from 60 is the square root of 3. So the sine of 30 degrees is the opposite over hypotenuse, so that'd be 1/2. The tangent of 30 degrees is opposite over adjacent, which is 1 over square root of 3. We don't like square roots on the bottom, so square root of 3 over square root of 3. That would give me the square root of 3 over 3. And the cosecant of 30 is the reciprocal of sine. So that would be, sine is 1 over 2. So the cosecant would be 2 over 1, or just 2. How many got those correct?
Yo, I did my
Nice. That's very important that you get that stuff. That's
Thank you.
good stuff. Well done, Aiden. All right, try another one. How about
Are you giving us more warm-up?
the cosine of let's see, 120 degrees. Try that.
Continue.
All right, cosine 120 degrees. 120 degrees is somewhere over here because it's 90 plus another 30. That's 120 degrees.
30.
Guess again.
What?
60 degrees.
Stupid.
So that's 60 degrees. That means this is 30. Cross from 30 is 1, 2, square root of 3. So now we need to figure out which of these is negative. Hypotenuse is always positive. Is the one positive or negative? It's negative. We're going left, and that one's positive. Okay, so the cosine of 120 degrees, same as this reference angle, so it'd be negative 1 over 2, negative 1/2. How many had negative 1/2 there?
We have the graph right.
All right, so we're getting there. We're not perfect. We've not completely mastered it. How about number 5?
Oh my god, I literally ran out of room this time.
How about the tangent of 225 degrees? Without a calculator.
Maybe that's what happened last time.
It probably did. My computer doesn't work half the time.
It's 1.
All right, so tangent of 225 degrees. 225 degrees is 180 plus another 45.
Sprinkler's evil.
So 225 degrees has how big of a reference angle?
Give me a cookie.
45. 45 degrees. Very good. So 45, 45, 90. That means this is 1, 1, square root of 2.
We're all so smart.
This is negative. This is negative. This is always positive. All right, so we have the triangle drawn.
-1.
Now we have to figure out what the tangent of that angle is. That's opposite over adjacent, so negative 1 over negative 1, or we get positive 1.
Wait, what? Is that
Negative.
how math works?
Negative divided by negative is positive. Yeah.
Well, I was right before.
All right, so same sort of thing. I'm just going to give you one more step. I'm going to tell you to, well, evaluate something with a radian measurement. So figure out the cosine of 11 pi over 6, please.
Do I have to?
Negative 2. Yes, negative. Oh wait, I thought this can't be negative.
Yo, I'm so giga-brained.
Can't.
Literally the smartest person ever.
Because it just can't. It's a rule of math. Like, y equals mx plus b, it just doesn't change.
I'm dumb.
All right, so my reference angle is 30 degrees. Because 11 pi over 6 is 330 degrees, it's almost all the way around, so that's 30. So this is 1, 2, square root of 3. That's a positive, that's a negative. So now we can answer what is the cosine of that angle? It would be square root of 3 over 2.
Mr. Winkler, your drawings are so articulate. You could have been an art teacher.
He is an art
Do you like that?
teacher.
You could have been an art teacher.
He is an art teacher.
Well, did you see my snowman in the back? Pretty impressive.
Where is it?
Why did Frosty get a divorce? His wife was a total flake. All right, are we good with those types?
I guess.
I think I'm.
How many got that one right? All right. So the only thing I didn't do is do like an angle bigger than 360. So I could have said like 390 degrees, and you'd have to go 360 plus another 30. Or I could have done
Do you have to do anything?
nothing different. You just draw it, and you draw your reference angle, and everything is the same. So figure out how many degrees it is, find your reference angle, draw the sides, and you can evaluate the functions. Okay, so we're moving on. But what if I asked you So all of those, if they are special right triangles, so if they have a reference angle of 30, 60, or 45, all of those can be solved without a calculator. I might also ask you to find the sine of pi over 2. Okay, sine of pi over 2 is something that you could do without a calculator. How big is pi over 2 in degrees?
Yes. No. 90.
Well, it's 1/2 of a pi. 1/2 of pi. Pi is the whole thing, so half of that would be, you're right, 90 degrees. So, what is the sine of 90 degrees? That's the same as the sine of 90 degrees. Here's how we find it. We use a unit circle. This is new. On the unit circle, if we have a unit angle or unit circle or anything in math that it says unit, it means basically it's magnitude of 1. So the radius of this circle is 1. That's the radius, it is 1. So if that's the case, what is this ordered pair? If I ask you on the graph, what is that ordered pair right there? What comma what? 1 comma 0, very good. What would this ordered pair be right there? 0 comma 1. And it seems simple, but this is literally how you have to do it. This is half of your work. So right here, it is what comma what? Negative 1, 0, and then this one is 0, negative 1. Okay, that's half of it. The other half is knowing that the sine corresponds with the y, and cosine corresponds with x. Because any points on here, what's the radius of that circle? 1. So if I call this ordered pair x comma y, that means I went over x and I went up y. What is the sine of that angle? Right here. What's the sine of that angle? Y over 1. So it's literally, the sine of that angle is y. Look at, sine is y. What's the cosine of that angle? What's the cosine of this angle? X over 1 or x. So remember that the sine is y, cosine is x. So, here's the question. What is the sine of pi over 2? That is the y value at that ordered pair right there, because that's 90 degrees. So what do you think it would be? What's the y value there? What's the y value right there? 1. Sine of pi over 2 is 1. Okay, using the sine of pi over 2b. What's the x value at pi over 2? It is 0. Cosine of pi over 2 is 0. Okay, in your notes, well, I'll do a couple others. How about the sine of pi and the cosine of pi? Try those. Everybody try those. See if you understand this. Okay, you should be done if you understand what's going on.
I'm still writing it down.
Pi is how many degrees? 180. So we're looking at that ordered pair right there. Right here. What's the sine there? It's the y value. So it's 0. What's the cosine of pi? Negative 1. Okay, anyone that lands on these axes, just think of the unit circle, your ordered pair, and remember that the sine is the y value, the cosine is the x value. All right, that would be pretty much all of 5.3.